All right, so welcome to Further Maths, and this is our first area that we're looking at, data analysis. So basically it's statistics stuff. So we take data and we use statistics to analyse it, to draw some conclusions out of that. So this is what we call core, so everyone in the state does this stuff. All right, so first of all, what we're going to look at is what we call univariate data. Okay, so not a very good U down the end there, but it's univariate data is the first thing. So univariate data, what is it? Univariate data has, what we have is one variable. Has one variable. Alright, so whatever it is we're looking at just one thing. So some example could be height. So looking at height of something, colour of something, and so on. But provided we're looking at one variable, it's univariate. As soon as we put another one in there, it's no longer univariate. Alright, so first of all, types of data. So what types of univariate data are there? Alright, so first of all we start off with data. That's all data. And all data can be broken down into two parts. So it can be numerical Alright, so numerical, anything that you'd use numbers, say goals scored. Would be height of trees. Anything like that, anything that you would use numbers for. The next one is categorical. And so eye colour, for example. So how you spell eye? It's eye colour. For example, that's a category. Alright, now have to be a little bit careful though, because even though numerical data and categorical data, sometimes we use numbers to represent categories. And so things like postcodes, for example. Oops, can't spell properly. Postcodes, for example, they're numbers, but they're actually a categorical data because they're a number that we assign to a location. Alright, and so because the numbers are applied to a location rather than counting something or measuring something, then it is considered then to be categorical data, right, rather than a number. So there's these odd little tricky things that you need to be a little bit careful of when you're thinking about it. And there's been an exam question about postcodes and exactly that kind of thing. And it's very common for an exam question to be, particularly in the multiple choice, about this stuff. Alright, so let's have a look at each of those separately. So let's have a look at numerical, for example. So numerical can get divided into two groups. Let's make that one a little bit shorter. Divided into two groups. First group we'll look at is what we call continuous. So continuous means that we can have any value possible. Alright. And the key thing usually measured. Alright, so key thing there is measured. So if you're talking about if something's continuous, you say, do I measure that? And you go, and generally, if you do measure it, then it's continuous. So height, for example. Alright. So the other group of or type of numerical data is what we call discrete. And discrete, we only have certain values. Alright. So usually discrete then counted. Alright, so usually we count discrete data. So like goals scored, for example. Alright, now sometimes it can be a little bit tricky, and sometimes it's a little bit tricky in terms of our everyday language and things like that. So say, for example, shoe size. Alright, so normally what we would do is we'd say, oh, we go to the shoe shop and they would measure our foot, and so we go, oh, we'll measure your foot. That's continuous. But remember, shoe size comes in like 5, 5.5, 6, and so on. Or if you use European sizes, same sort of thing. So even though we talk about being measured, it's actually discrete because there's only certain values and they're halves. Alright, so that's why I got the words usually in front of those two things. Alright, so that's then the numerical. So the other one is the categorical data, so categories. So let's look at that. And again, that's split up into two types. One is ordinal. So there's an order, so something like a fitness level. For example, questions like, how much do you like? Blah, blah, blah. So there's some sort of order then, high, low, medium, so on. And the other one is what we would call nominal. Alright, and so nominal, it's a bit dodgy that word there. So nominal there, that's better. Alright, so nominal would be like things like colours of cars. Because there's no order, red, blue, green, yellow, white, there's no order in there necessarily. So nominal for that. Alright, so they're the types, and as I mentioned, there's often an exam question which asks you to identify types and things of data. And of course, the VCAR being VCAR, going to give some tricky ones. So just be careful when you're reading. Alright, so now we're going to displaying data. Alright, there's a number of different ways, and today we're looking at just categorical, or in this first bit, categorical. We'll get to the numerical in a later lesson, but for the moment, just categorical. Alright, so categorical. So one way we can is what's known as a frequency table. So frequency table, what does it have? Well, it lists the variable, also tells you the frequency, which is how many. Of each of those things. So an example of frequency table would be something like this. Alright, so there's our frequency table, just three things, red, blue or green in the colours, and then the frequency tells you how many of those things that there were. So there's 2 red things, 4 blue things and 6 green things, whatever the things were. Alright, now sometimes we can do this rather than just straight frequency. We can do it as a percentage frequency. So percentage frequency, we simply write the frequency as a percentage. And so your percentage frequency equals our count, so that's our count, how many of that variable, over our total count. Shouldn't try and talk and write at the same time. Times 100, and then that's percentage. So our previous table, if I'll bring it up here. Alright, so there's our previous table. So this is frequency as a number. Now if I count all of those up, there's 2 plus 4 is 6 plus 6 is 12. So our total count is 12. And so if I want to know my percentage frequency, then I do my count, which for red is 2, over 12 times 100, and I'll get 16.7%. For the blue, it's 4 over 12 times 100, which is 33.3%. And the last one, of course, 6 over 12 times 100, and that's 50%. Alright, so that's a frequency table, either just a normal straight count or percentage. Alright, another thing for categorical data is what we would call a bar chart. Alright, so bar charts are used for categorical data. They're similar to what we call histograms, but they're not the same. Alright, so a bar chart, we can have bars this way, or we can have bars this way, horizontally. That's all good. Now you'll notice that I've got gaps in here. I've put gaps. Now I've deliberately put gaps because a bar chart has a gap between the bars. Alright, so it's most important that you have that. Otherwise it looks like what's called a histogram that we will do later. Seeing as these are categories, then categories don't necessarily, are not going to butt up against each other. It's not like something that we measured and then we roll over into the next one as we measure. These are things that we're counting how many of blue or how many of green, and then so they're separate things. So let's have a look at an example. Alright, so here's our example. Our example here, we've just counted some cars in the car park or something. And there's the results. So I'm going to do a bar chart. I'm going to do a vertical bars. And so here we've got our colour. And so red, white, blue, green and other. And up the side here I might go up by 5s, so 5, 10, 15, and this is my frequency. Alright, like so. And then I just draw my bars. So I'll draw my bars. So the red bar goes up to 7, so 7's about there. The white one goes all the way to 15. The blue one goes to 4. The green one's also 4. And the other one, that's up to 8, like so. So there's our bar chart. So you notice there I've drawn it with the the gap. Ideally the gaps between each one should be the same and the width should be the same. Pretty rough and ready what I've done just by hand. Alright, so that's a bar chart. Now there's another kind of bar chart variation. It's called a stacked bar chart. So for a stacked bar chart, instead of having all our bars all separate, like that, there's all our different bars all separate, what we do is we take them and we stack them one on top of the other. So for a stacked bar chart, you would just have one scale there like that, and so let's go up by 10s. To 40, I could have spaced it out a bit better than that, but anyway, it is what it is. Alright, so first one there, red, there's 7. So what I can do is I draw a bar that goes up to 7. Then the next one after that's 15. So 7 plus 15 is 22, so the next bar stacked on top of that comes up to 22. And so that was white. Then we stack on top of the white, the blue, which is another 4, so 22 plus, so that's 26. And then on top of that we stack the green, which is 4, so up to 30. And then the last one, others there, 8, and so we go up to 38. Alright, so it's a stacked bar chart, and often they'll be colour coded and all look all nice and pretty and all the rest of it. Alright, you should draw them with a ruler rather than being rough like me, but you get the idea. Alright, so you should have seen these things last year in general. So hopefully it's a bit of a review for you. Any questions, of course, make sure that you do ask. So now on your work plan. On your work plan, we're looking at exercise 1A and exercise 1B questions that are listed. Alright, and of course don't forget to like and subscribe.